Okay, in this video, we're going to look at different types of angle relationships in circles. If you're watching this in the year 2020, then this is our last section on circles. If not, if you're watching this in the future, little fun fact, in the year 2020, we actually had to learn at home for March, April, May, and June. Well, hopefully not June, but we'll see, because there's a pandemic. So hopefully for you people in the future this sounds weird because it's not something that happens often, but a little fun fact in history. But if you are in the future, there are other sections that we're going to do, but for my students now in the year 2020, I just want to say I miss you guys. And also, this will be all we'll do with circles. If we have time at the end of the year, we'll come back with some other circle stuff, but it's not that important. We'll hit it back later. Alright, so first we're going to look at what happens when a tangent and chord intersect on Geogebra. Okay, so I'm in Geogebra. I constructed a circle. Now I'm going to construct a tangent. So that would be down, I don't know, let me hit pause and find where tangent is. Okay, there it is, tangent line. So I'm going to hit this circle through this point. So that's a tangent line. Alright, then I'm going to construct a chord. Now a chord is just a line segment, so we can use the segment tool. And I'm going to place it right there. So that point C is on the circle. Good. Okay, now we know that if I put the chord through the center, that this angle right here, angle B, angle ABD would be a right angle because a chord and a radius always intersect at a right angle. Now if you look at this arc here, I don't know if you could see my arrow, but from B to C, that would be a semicircle. That's 180 degrees. So if I put another point here, arc BEC is a semicircle. Notice how angle DBA is like an inscribed angle. Its vertex is on the circle. So it's similar to an inscribed angle, but it's not quite because it's not made up of two chords. But if you have a tangent in a chord, you can treat it just like a semicircle. Just like an inscribed angle. So you can assume that angle DBA is 90 degrees because it intercepts an arc that is 180 degrees, this semicircle. Okay, so I just added some angles here. So this one that says 179 and now 180 degrees represents this arc measure, and this angle DBA is 90 degrees, so it's half that arc. And if I were to adjust this chord, so let's say now this arc BEC or minor arc BC is 120, this angle here is going to be 60. All right, it even works if this angle is bigger, so it's going to go the other way. So it's kind of weird, but like let's say let's put it right there. Alright, whatever, I tried. So this angle is 102, roughly, which means that this arc right here would be 204 degrees. And if you subtract 204 from 360, you get 156, which would give you this remaining measure of arc BC, which makes sense because that central angle is 156. Alright, so if you have an angle made of a tangent and a chord, and its vertex is on the circle, like point B, you could treat it just like an inscribed angle. So if you look at that theorem here, that's what we just learned here. If you want to pause the video and jot that down, alright, now would be a good time. Alright, so angle 1 is half the measure of arc AB, angle 2 is half the measure of arc BCA.